Dr. Stephen Alonso here of the Flat Earth University, and I want to talk about the problem with people denying that there's a 24-hour sun in Antarctica. Now, to clarify, this has nothing to do with the final experiment. The final experiment can be completely fake, and it changes nothing about what I'm talking about. The core of the problem is that prior to the final experiment, we knew there'd be a 24-hour sun in Antarctica. It should be nothing that should have surprised anyone. Every flat Earth model predicts it. Every observer-centric calculation shows it. I even published it in my book, page 130 of the Flat Earth Science textbook. This was published in September, before December, the final experiment happened. So that's how confident I was and how we knew it. It's nothing that should have surprised anyone. Now, I'm aware of certain groups of people who have historically said there's no 24-hour sun in Antarctica, or that the 24-hour sun in Antarctica would debunk a flat Earth model. But what model are they talking about? The issue is that if you choose to deny that there's a 24-hour sun in Antarctica, you then have no model at all. You can't make predictions about anything anymore. And I'm one of the admins of the Firmament Trackers group on Facebook. We have 2,000 people from Australia and 500 from New Zealand. And these are actually people older than me as well. I'm only in my early 30s. Most of the group is in their 40s. These are mature adults, well-educated people who know how the sky works for them in the southern hemisphere. I understand if you are from the United States and you've never traveled and you don't believe how, I guess, other people's photos, everyone in Australia is fake. Like, it's hard to tell between the trolling or people who are serious and just don't know better, or people who are still at the junior level for flat Earth. The issue is, though, in Australia, we know that there's a south celestial pole. We know how the 24-hour sun works. The exact same predictions that you would make in the United States apply to places such as Australia. So, for example, in the northern side of our flat Earth, we know we have Polaris. And we know that Polaris will rise or fall by 1 degree every 69 miles that you travel to or from it. And we know that there's a one-to-one relationship between latitude and that angle. So, for example, if you're in the United States at 40 degrees of north latitude, that means Polaris will always be 40 degrees above your horizon. This location is also called the North Celestial Pole. Now, when you get to the southern hemisphere, people in Australia, people in New Zealand, they also have their own South Celestial Pole. Now, this concept on its own may be taboo, and you're like, there's no such thing as a South Celestial Pole. You may have listened to trolls, such as Flatzoid, who lives in South Africa, sees the South Celestial Pole every night, but just denies it because his audience is North American, and he's catering to that group. And that's the problem with flat Earth. It's hard to tell if someone just doesn't know better, or if they're just intentionally trying to mislead you. Now, again, I'm here to tell you what you need to hear, not what you want to hear. There is a South Celestial Pole. In fact, there is an infinite South Celestial Poles, because longitude is a continuous coordinate system. So everywhere you look south, if you're past a certain area, you're going to see the South Celestial Pole. Now, the rotation, though, of these objects depend on what part of the firmament you're looking at. So, for example, let's look at New Zealand and Chile. The Southern Cross constellation, that X, is not going to be in the same position. It'll be rotated up to 360 degrees around that South Celestial Pole. Someone in New Zealand will see it south, while someone, and I'm talking about like beneath the South Celestial Pole, like due south, but south beneath the South Celestial Pole. Someone in Chile will see it about east, like a 45-degree offset. That's very important to understand, because people such as, who's the guy, Professor Dave, he'll post photos trying to intentionally mislead you. He'll try to strawman how it works in real life as well by pretending that would be the exact same orientation. That's not true. It'll rotate. Now, there is a South Celestial Pole, and just like in the northern part of our world, that also rises and falls by 1 degree every 69 miles. This is nothing new, nothing complicated. And we have flat earthers who are from Australia who look up at this every night and know about this. they also see the path that the sun takes. But not only that, if you guys have ever used any of the Flat Earth apps, Flat Earth Pro, I believe, is a very common one. It's a 2D sky view model. Place your observer in Australia. You're going to see exactly what I'm telling you. It's nothing that should be confusing to you. We know the path that the sun takes, and we also know the physical location. This physical location is called the ground position, and it has a latitude and a longitude location. And this location isn't debatable. You can go outside yourself, look at the angle where the sun is highest above you, do a celestial declination calculation, and find the latitude. To clarify, there's a 1-to-1 ratio between the celestial declination of an object and its latitude. That's similar to what I mentioned about with Polaris. We know that if the angle of elevation is 17 degrees from your horizon, that means my physical location has to be 17 degrees. And that works for other objects such as the sun. If you see the sun at 23 degrees from your horizon, you walk 1 degree more, it's going to rise or fall depending on which way you're going. So we can do the flat earth math to figure out how our perspective would rise or fall. So we don't even have to start, well, we can start at Polaris if you want. So if you're at the North Pole and Polaris is directly above you, and you start walking away, you're going to find that it starts to drop lower and lower. And then once you're at the equator, you have both the north and the south celestial poles within your vision. As you continue south, that south celestial pole rises. Now, the location of the sun, the apparent location that we see, follows those arc rotations. So if you're in the United States, you'd be very familiar with that arc that the sun takes as it travels around you. And then as you move closer towards the North Pole, that arc rises up and continues rising up until when you're in the North Pole, it's completely rotating around you. That exact same thing holds true in the South. And it makes no sense why it wouldn't. If you're in Australia and your south celestial pole is like, let's say, like 30 degrees above your horizon, if you continue going south, that arc will rise up and up and up and up to eventually you get a 24-hour sun circling you. I don't understand how this can be confusing to anyone. You would have to understand where the physical sun is and how there's an apparent sun that we see due to perspective. I don't know if that should confuse you at all. I can show you how it looks on the flat earth model. Let's put it, I guess, this space right here. You'll be able to see how the physical sun, which is located at the Tropic of Capricorn in December, is doing circles above our flat Earth, and then every observer sees it depending on what angle of refraction is going through the firmament. This is visually how it works. This is how it works on flat Earth, and there should not be any issue with that. If you reject that, you then have no model. You can't make predictions for anywhere. You really can't at all, because even for me in Belize at 17 degrees of latitude, I'm still in the northern hemisphere, but the south celestial pole, the Southern Cross, it's possible for us to even see that. So if you're going to deny all of that, you're left with just like this very tiny limited area, and it becomes a joke. You honestly should just believe in the globe. If you're going to deny the 24-hour sun on flat Earth, you should believe in the globe, because at least then you'll be able to make predictions. And you don't want to be like the Nathan Oakley cult, where they said flat Earth has no model, we make no claims, Earth is measured flat. That's ridiculous. And it holds you back. And there's an issue right now where people have some emotional attachment to there not being a 24-hour sun in Antarctica. And it makes no sense to me when the math predicts it. Every flat Earth app we've used predicts it. We've known about it. And a few people might have said they don't think there's one, or they might have thought that there are. Like, they may be genuine that they didn't think there would be a 24-hour sun in Antarctica, and they may not understand how it could work, how the math works. They might not even believe in the South Celestial Pole. So for them, it could debunk their understanding of flat Earth, and that's perfectly fine. But to have everyone else repeat that when they should know better, and then to make it worse, those of us who are senior flat Earth researchers in the senior level group, such as the Firmament Trackers group, we all knew there'd be a 24-hour sun. We're expecting it. It's how the math works. People who understand the science and math and who can calculate it, like yes or no, do a 24-hour visibility formula. Is there going to be a 24-hour sun? Yes or no? Okay, yes. Then yeah, it's going to happen. You cannot deny it, or else you can't make a prediction about anything. And I actually retract what I said earlier, that you'd be limited to just a small little area in the north. You'd actually be limited to nothing, because in the north, we still know that perspective rises and falls by 1 degree every 69 miles. Why would it magically stop past a certain distance? And then if so, how does that work? Like, it's completely ridiculous. We know that there'd be a 24-hour sun. We know the math. Guys, I can't understand it. So the problem with denying that there's a 24-hour sun in Antarctica means that you have no model. You can't. So people like Nathan Oakley are correct. They have no model. They can't make predictions. They can't make any claims. And all they can do is say Earth is measured flat. And they're correct. From a local reference frame, Earth is measured flat. I agree with that. But how do we know like where the sun will be, the time of the sunrise or sunset, where like you end up having nothing? And it's a real big problem. The influencers who have spread this bad idea that there's no 24-hour sun, they might not have known better. A lot of people like Flat Earth Dave, he's not a scientist. He honestly doesn't know better. And we have to look at this in the evolution of science, similar to how Einstein improved upon Newton's theory of gravity, the mass attracting mass. Einstein did not necessarily debunk Newton. He improved on the existing theory. And we have to understand that's how the progression of science works. So people who claim that there was no 24-hour sun, they're wrong. Okay, so how do we understand how it actually works? And that's very simply by understanding the flat Earth math, understanding celestial declination, and understanding how a 24-hour visibility formula works. And then looking at it on the flat Earth maps. These are all Gleason maps. That's how the world really looks like in real life. So you can see how the sun's circling. You can see the observer's perspective, seeing how they see this. And I think we got to move forward. It's surprising to me that this is still an issue. It seems that the focus has now been on whether the final experiment was real or fake, rather than how does the flat Earth model predict a 24-hour visibility at a certain latitude. I don't even care if the final experiment was real. It could be completely fake. It doesn't change the actual math and the predictions and the observations that we've had for years before that. So I think it's important that we move past the idea of whether the final experiment was real or fake, because it actually doesn't matter. The final experiment confirms what the flat Earth model predicted, but that doesn't mean anything unless we have the math and the theory to back up that conclusion in the first place. So even if the final experiment was fake, it doesn't change the math. It doesn't change how we knew prior to that there would be a 24-hour sun.